Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about AMD Ryzen 7000 Non-X that has been released recently. So let's dive deep into it. So this was a CES launch which happened very recently, and they released a slew of basically CPUs like 7900 without the X, 7700 without the X, 7600 without the X. That's why we call it Non-X. And it's basically whole CPU line clone copy pasted and without the X. And the core aim with this puppies is low cost, meaning it's supposed to be easier on your wallet, and very importantly low power draw also, meaning it should be easier on your electricity bill. And the medium range is 65 watt TDP. Now be mindful, 65 watt is very good for the first two, but the third one is like pushing it, and the real world power draw is generally around 100 watt, but be mindful that is limit. You can push past it if you have motherboard that have unlocks the performance. If the motherboard is designed for that kind of TDP, you can unlock it. So there is no limitation on these puppies, meaning you can buy it, and if you have good cooling, let's say you are carrying forward a let's say liquid AIO, you can literally go YOLO on it and you can get almost the similar performance as the X variant for lower price. So you can do that. For everybody who wants that low TDP, they are generally also providing you included box cooler, and these coolers are actually good, and given the fact that power draw is low enough where it can actually work. So if you want low power draw systems, these are your best bet. So what about the price? Now price war is going on recently on the CPUs world, and it's a very good thing. We always wanted this, but back in the old days we had Intel for people and AMD for poor people. So thankfully that has changed. Ryzen was like slowly Ryzen at first was like, oh, okay, then it was like, yeah, it does have some productivity boost. Then it is like, no, if you want productivity seriously, go with AMD. Then it's like by AMD Ryzen 5000, first time properly AMD's victory happened. But 7000 was not as clear cut. Again, it has some quirks, but it also lost in some, so not as clean cut. But it's amazing. We want this. That's how prices are always level. And if you ever wonder why the heck NVIDIA can keep charging whatever they want, because they do not have competition. So this was awesome. So price war that is going on right now. Be mindful, these CPUs are lower cost compared to the V series they're gonna release with a vertical cache. That will be higher cost, but they're releasing lower cost in CES. That's a very important thing. So the reason for that is AM5 platform. Now AMD had made a good investment in the past where they're like AM3 plus supported for long, AM4 supported for long, AM5 they also want to support it long, but AM4 to AM5 jump is a bit expensive simply because they want to dump many of the unused technology. For example, DDR4 will be dumped for DDR5, PCI4 will be dumped for PCI5. Now these technology are inherently expensive and many people are not getting it. It's like Intel also tried to do this, but Intel only has cycle of 2 years, basically 2 motherboard processor launches per motherboard socket. So they are like, okay, this socket 1, 2, throw away. So Intel did try to do that DDR5 launch with 12th gen, but problem was at that time cost of DDR5 was too goddamn high. So Intel did not sold as much, and be mindful, this is the same time AMD 5000 was genuinely like fundamentally ahead. So there was like the sales were really bad, so they caved in and gave DDR4 option. Problem is the moment ever you do this, people always choose the cheaper option. It's like if you ever wonder why people complain about like Android phone so much, is because every single Android manufacturer is smoking cocaine, and they are like, hey, let's give RAM options. You never give RAM option, because here's the deal. What Samsung does is like, this mobile phone comes in 4 variant. You have 4GB RAM, 6GB RAM and 8GB RAM, and they will give for all the reviewers 8GB variant, and people are like, hey, this is amazing. Person goes to the shop because they say the price starts at 21,000. They are carrying 21,000. They go into the shop and it's like, I can only afford 4GB one. But again, the reviews were good. Reviews were good because it had 8GB. You buy 4GB one and it's garbage. You never give cheaper or inferior option, because it always comes back to bite you in your brand recognition. This is one thing that Apple truly understands. They never let you have a poor infrastructure. It's like, if you want poor, buy something else. If you want a good experience, only then come to us. So I do understand from AMD's point of view, where they are like, you have to come to AM5, you have to go to DDR5, and you have to do PCI 5.0. Sooner or later, these things will happen. So somebody has to be the first one, and they're like, okay, this is our time, AM5, DDR5, PCI5, let's just bite the bullet and bear the upfront cost. They did that. Consequence, that made 13th gen look like good value. Raptor Lake actually is for cost competitive. So you can literally buy Intel that is a bit more performing than what you can buy equivalent AMD, while costing less in other things also. For example, the motherboard, the RAM, all that jazz. So this was basically non-X release was almost like a tit for tat kind of countermeasure. So non-X are cheaper options. So that's the first thing. And because it's not locked, you can truly achieve almost the mind-boggling performance. That's good, especially if you do not even have to include the cost of the coolers. Coolers are very important for Intel. We'll talk more about that. But be mindful before you jump, into your purchasing detail or cart. I would urge you check the street price basically, as in like any online retailer that is near you, your locality. Prices are fluctuating a lot, so be mindful, be cautious, apply some brakes, take some deep breath, only then jump into it. Relax. Prices are like fluctuating a lot right now, and we want that. We want like this sort of competition. We want companies to like, oh, we cannot just keep increasing the price however we want it. We have to actually make it cost effective. That's what we want. We are happy about it. So we come to two core vectors that are happening here, and it's amazing that at least these two things are as an option available. One is efficiency, another is value. Value means how much oomph you get out of your dollars, whereas efficiency means how far can you run per dollar, as in like electrical consumption. So 13th gen Intel does have a total cost of ownership, simply because again, cheaper motherboard or last gen motherboard, DDR4, all that jazz is there, and processors are generally a bit more powerful. So that's awesome. However, you do pay a penalty for that. Intel is like, because again, Intel has been backfunded specifically with AMD 5000. It was like done. AMD 5000 was genuinely that good. Whereas like, buy AMD, done. Like it was not like, oh, if in this workloads, no. Buy AMD, done. So Intel really pushed hard, and that's why you will pay attention to basically Intel's 10th gen, 11th gen, 12th gen, 13th gen. Nobody even talks about 11th gen because it came so quickly. The gap between 10th gen in the market, 11th gen, 12th gen, all happened quickly in months, simply not even a year, months, simply because AMD was that good. And we want that. So Intel directly boosted their throttle and they got a lot of performance. Problem was that performance come with a penalty of power draw, meaning these puppies, basically wrapped 13th gen, they consume power like there is no tomorrow. Like they consume, they are almost reminding me the good old days of AMD Bulldozer, which I have. FXA 350 is like a room heater. They consume that kind of power. I'm not even joking, they actually draw that kind of power. So you have to understand, you are saving money when you are buying into an Intel system, but you may not be saving that much money, specifically when you consider your electricity cost. So what sort of people should buy, AMD system? What sort of people should buy Intel system? Well, this comes down to your need. Exactly what do you need with your system? So if you are a low system usage, basically your computer is only on for, let's say, 1 or 2 hours per day. Let's say you work a very heavy job, you come home, you barely turn it on, play it 1 or 2 hours, then go to sleep. That's low system usage. In those sort of scenarios, you need maximum performance. Basically, I'm only running this car for a little while, but I want the most latest and greatest performance. Mileage be damned. You want that. In those scenarios, buy Intel. If you're in a scenario where it's like, let's say you work from home, or you're an individual who's like for me, like I render video daily. It's not something like, oh, once in a while I render video. No. That's a daily thing for me. 2 videos per day, minimum. I may even have like extra shot here and there. So in those sort of scenarios, I need max efficiency. At that point, it's like, if you have a car that is needed for job and you drive for long range, you need mileage more than anything else. So these are the two categories. You have to figure out where you sit. Because you have to pay penalty. You may be like, hey, Intel is giving like, a lot of performance for low cost. It's like, yeah, the cost is your electricity. So if you have mild uses, you may find something in between. Or if you're like extreme ends where it's like, I rarely use it, get Intel, enjoy. If I use it 24/7, not 24/7, but like, 18 hours a day, go with AMD. So you have to understand, if I work from home and continuous use, please go with AMD, because I'll explain the power draw conundrum further. At large scale, like why the heck AMD released a processor that is like inherently inferior to their own? Well, reality, it was not targeted for you and me. It's targeted for large scale, meaning OEMs, basically Intel, I'm saying basically AMD, Intel, both sell bulk CPUs to, you have HP, Dell, Lenovo, these sort of manufacturers, bulk manufacturers. So these CPUs are core focus for that, bulk buying. Basically, if you're ordering 1,000 of these, 10,000, that's what they're focusing on. Why is that? Like who consumes that kind of PC? Office, corporate, design studios. Like I worked in gaming studios. Like I have seen, went into interview also, multiple gaming studios, they all had HP workstations and hundreds of it in one floor. So you can easily find a system where you have hundreds of this working in a small area. Now, what's the core benefit of non-K? Basically, low TDP. What does low TDP mean? Inherently low current draw on your power wires, on your electrical bill. That directly saves you money. And these are serious amount of money. My small studio, which had only like around 600 people, gaming studio, it was paying bill that was like expensive amount of money per day electricity. So saving electricity there mattered a lot. So having a processor that is like good performance but not consuming too much power, it's a godsend because it saves you money in terms of your power draw. Another aspect is all these systems are like high priority systems, so generally run on what we call online UPS, which are like double conversion UPS. If you have very high draw, you have to buy a expensive larger capacity online UPS. So that also matters. It's not just like, oh, I'm paying bill. There is a very good chance you have online UPS, and those puppies are expensive. So buying a, let's say something 5 kilowatt rating, that's expensive. Buying 10 kilowatt, that's idiotically expensive. So if you're like, hey, how about we fit everything under 5 kilowatt, that's good. And once you do that, that's the electrical side. Another side is thermal. Low TDP means low heat output. That simply means your air condition also consumes less power because they are steel. All these things are working, crunching number, inherently meaning they are acting like a heaters. So that's heater, and not to mention every person there, minimum if they are sleeping on the chair, that would be around 100 watts of thermal output. And if they are actually working high blood pressure, they could be releasing around 150 to 200 watts of heat. So that's a heat load is there. Your air conditioner has to cool it down. Now, if your computer's chassis itself is like, instead of let's say 150 watt of thermal output, it's dumping 350 watt, your AC is like, yeah, I'm gonna need some electricity. So your power consumption goes exponentially, and not to mention also shortens the lifespan of the air conditioning system, unless you now go to supersize it. So instead of 10-ton air conditioner, you need 20-ton. That's why for those sort of people, this sort of processor is like shut up and take money. And that's why every time you look into server processors, you always find their clock speeds are always lower. Why? They always focus on efficiency because they have maximum utilization. For them, performance per watt is the most important thing. They will be happy buying few more processors if they have to, if they have a performance per watt that is low enough. Because again, they are running it 24/7 into 365 and trying to push it to 100% continuously. So at that point in time, electricity does pile up. And not to mention air condition does pile up. So for large scale, they're like, they have already bought and sold. They're like, done, bro, done. AMD literally did this for 5000 series, but it was like OEM only. This is the first time that we are getting, mortal people are getting access to this efficient technology. And this future that companies launching energy efficient variant is awesome because power draws recently went stupid. Why? Well, graphics card are the first thing for it, because again, there is no competition in GPU market. So NVIDIA can just go lol. They can just go YOLO. And the reason why people are saying that RTX 4000 series has idiotically large GPUs is like, as in like heat sinks, is that original design intent was like, maybe we require even more power envelope, as in like 400 or 600 watts. So they designed it like, again, these designs are done parallelly. So they overbuilt the coolers. Not overbuilt as in like they assumed they're going to be generating more hot. So why the heck they can even think that's valid? Because again, they are just pushing it. Everything is slowly pushing up. Pushing up. So we are reaching a point where manufacturers flat out on their website will say you need 1000 watt PSU. Be mindful, this power rating of power supply unit always used to exist. It was a common thing in server. It was common thing on people who had like multiple graphics card, but it was never common thing for one CPU and one GPU. It was never common for that. Like back in the days, you can watch videos, they were like, oh, you 650 watt is more than good enough. 850, you good, you solid, you stable. Now it's like, dude, 850 is bare minimum for RTX 4070. It's like, what the hell? So this idea of like going power up, like brick by brick, like 3000 series is like, you know what, 800 you really needed. Now it's like 1000. What will be the next 1600 watt titanium power supply? It's like, what the hell? So this cannot keep going on. Fundamentally, this cannot, because prices of energy is going up, and it's going up planet-wide. For example, it's going up in India, it's going up in Pakistan, it's going up in Sri Lanka, it's going up in USA, it's going up in European Union, it's going up everywhere. So it's not like, oh, you are not affected by it. No, a whole planet is affected by it. So at some point, this sort of ludicrous power draw will come back to bite us in the ass. That's why I specified, if you are using your computer a lot, pay attention to performance per watt. And we need that performance per watt, not super high performance. To give you an example of that, 12th gen, a good processor, like anybody who has 12900K is not gonna say, oh, I have a bad processor. It's like, it's a good processor, really good performance. Now, this puppy consumes 240 watt to give X amount of performance. Awesome. But here's the Raptor Lake could easily give that baseline performance at 65 watt. Let that sink in. Same performance at 65 watt of power draw. That means if we were not chasing performance for performance sake, we could have easily capped it up to 100 watts and still be better than this one. Because they were losing compared to AMD, they literally pushed it beyond. Let's say 65 is more than good enough. 100 watts should have been like comfortably high enough. They pushed it to 253 watts and then only got 41%. And this is from Intel. By the way, real world data is like 350 watts of power draw, spike power draw, and continuous power draw of around 270 watts. That's a serious amount of heating element. That's just mind. If you are drawing like, let's say 290 watts, does not mean you are drawing 290 watts from the plug. You must be drawing far more than that from the plug. So this sort of, you can see that. That's why it's like server focus are always on that, like bare minimum power consumption, maximum amount of workload per watt. Because again, you are not only paying for the electricity, you're also paying for the cooling. So both things do go into the equation. So this sort of processors are not the high and mighty processors that we want, but it is the processor that we need. We need performance per watt more than we need super high performance. It's like, dude, a game that is running at 130 FPS, that's good. A game that is running in 350 FPS, really not that good, simply because how many of you have monitors that can render that point? Like what we call point of diminishing return. 30 FPS, okay. 60, good. 120, like this puppy, like this monitor is TV is 120 FPS, really good. What about more than that? Yeah, you're reaching a point where it's like just doing it for the doing sake, point of diminishing return, like beyond 120 FPS. Like if I have a high speed camera, it's like, dude, unless you are making money playing games, it's reaching a point where it's like you're just doing it for doing sake. And I really like the idea that AMD is thinking there is enough of a demand, and I'm reasonably sure by the time people are paying attention to, and more reviewers are also paying attention to how much power draw is there, Intel is like, bro, 350 watt spike load, that's brutal. Like back in the days, whole computer used to run in that power envelope. So we really like that, like this approach of going into low power consumption. Because right now, if you really want to make a high performing low power consumption system, you can buy a GPU from NVIDIA that is A213, I think. It's a low power card. It's inherently translation to is like RTX 3060, but it has 12 GB ECC RAM, so it's designed for it's a quadro card basically, and it's low profile, does not have power connector, like flat out there is no power connector. It runs on board power. Buy one of these AMD system that is again maximum law, do not unlock it. It works inside 100 watt, run on box cooler. You can have like a literally home theater system which can do good gaming. If you do not turn on ray tracing and all that jazz, you're gonna get good experience, as in like hundreds of FPS for very little amount of power, like around 250 watts of power. Actually less than that, you can go less than that if you do not have too many NVMEs. So I really like this approach where it's like, instead of just going more power, even more power, it's like, bro, we have to pay for the power. So I'm really happy. Like there was a point where I was like not sure which one should I buy. Like, should I buy Intel? Should I buy AMD? Because of my UPS, I'm like, bro, I cannot touch Intel. Yeah, no. I touch this, my UPS is like, I'm out. So this is one thing that I'm really happy that AMD is doing, and I'm reasonably sure because of this, Intel's 14th generation will have pay specific attention on energy efficiency, because they cannot just this number go up. There's a point where people are like, bro, I can't afford the number go up. So this was my presentation on AMD's non-X 7000 series CPU lineup. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me a disappointment. If you want to comment, I would love to hear from you. I do reply to all of them. And subscribe, press the bell icon if you're free. And as always, thanks for watching.